Welcome, everyone, and thank you for joining us today. My name is Paul Donahue, and I will be your host. We ask that you please keep your device muted during the session, and if you have questions, please direct them to me via the chat function. We'll do our best to answer questions at the end and to follow up with any unanswered questions via email. As I think you know, these Tech Talks have been designed to provide straightforward insights into radio frequency components, the related technology, and the extra design and engineering value that is added by a custom manufacturer such as Quantic TRM. To begin today's session, I am once again pleased to introduce Quantic TRM's Chief Technology Officer, Shaun Moore. The author of 2 U.S. patents and a number of white papers and technical articles on passive microwave technologies, Shaun has been with Quantic TRM since the late 90s, and his passion for the job and for solving problems has only increased over the years, especially when it comes to resolving our customers' design and engineering challenges. So welcome, Shaun. Can you share an overview of today's topic and your objectives for the session?
Yes, thank you, Paul. I'm going to talk about manufacturing technology and what has changed over the past several years. So we're going to open up basically by speaking about the various diverse processes that TRM can build our products to. We certainly don't behold ourselves to just one method of manufacture. We'll start with some of our baseline historical sort of methods that we use for building and designing our products. Then we're going to move into some products and some processes that are more recent to TRM, things that you may or may not be aware of. Things like using multi-layered PCBs in various incarnations. You being able to use solder reflow as part of our manufacturing process, and also using surface mount products, both in our products and as an end product to our customers. Then we'll go through some TRM differentiators, and we'll round it up with a summary.
Well, thank you. That sounds good. And to get started, to describe the manufacturing technology and some of the advances, is it fair to say that it all begins at what you've referenced here as baseline methods?
Absolutely. So, really from a baseline technology, TRM in excess of 50-year history started off building circuits pretty much by hand. Our founder was very much an expert in lumped element technology. That is very low frequency broadband type products. These sorts of products are made with wire wound transformers, capacitors, and those sorts of components to build up really power dividers, hybrids, and couplers utilizing that technology. This is one of our core competencies, and I think that TRM is quite good at it. This sort of manufacturing process does lend itself to hand operations. These transformers are quite small and difficult to use in a pick and place machine, but they from our standpoint perform quite well. Moving on to the next type of technology that TRM uses is microstrip. Microstrip is a distributed element technology rather than a lumped element technology. So the math is a little different as far as for designing these things. But TRM has a very long heritage of designing and manufacturing microstrip products. The thing that's key to microstrip is that it uses a single bonded board into a housing. It is a distributed line technology, and it is used for higher frequency type components. I'm going to talk a little bit later on as to how we've now taken a standard microstrip product and how we've developed that into how we've advanced the way we're manufacturing that to help speed up our manufacture as well as increasing our quality. But really, I think that the thing here is that it is a technology that we've been doing for quite some time. I might as well go into it right now as far as to really thinking about a little bit what's different now is as we have automated a lot of these processes for the manufacture of whether it's a microstrip product or a lumped element product. So we'll get into that a little bit later once I just actually get to it in the presentation.
Okay. And I've also heard you speak about strip line and maybe a few other technologies. Can you explain those?
Sure. So again, strip line, as I mentioned in the past, is a sandwich sort of technology. This has mechanically compressed piece circuit boards from our heritage sort of design work. Uh, Once you move into strip line technology, you're now out of the planar sort of manufacturing process. You can now do multi-layer boards. These sorts of constructions are fully tunable. You have mechanical vias running between the layers um, in order to be able to build a strip line type part. Strip line is also very good for building high frequency couplers, directional couplers and hybrids. It is our main technology for building those sorts of products. Um, other sorts of technologies that the TRM has historically built are coaxial components, most notably rat race hybrids. We've also built quite a few lower loss components in suspended strip line and coplanar waveguide for some higher frequency, lower loss types of components.
So if these variations are all what would be referred to as baseline technologies, what about some of the more advanced categories? Can you talk about those?
Sure. So now, really, I think one of the exciting things that I think that TRM has been moving into over the past, say almost 10 years now, is moving into a multi-layer PCB technology. One thing that TRM always prided itself on was being able to manufacture in-house virtually everything that we designed. About 10 years ago, we decided to move away from that exclusively and basically expanded our manufacturing capability by using outside resources, especially for multi-layer PCB fabrication. Multi-layer PCBs offer several advantages. There are also downfalls. It's not always a win-win-win when you change technologies. Uh, the nice thing about multi-layer PCBs is that it allows you to get a lot of the mechanical interconnection between the layers of the circuit board into a machine-based manufacturing process. So the interaction between the layers becomes very controlled. In addition to that, it reduces the part count and it also reduces manufacturing variability by going to a machine-based manufacturing. So there's a lot of advantages to going to a multi-layer PCB for these multifunction modules um, in that process and removing variability, which is very good for all of our customers. The other thing that you get when you move into a multi-layer PCB is that it allows you now to build components that utilize this sort of construction technique of going into a bonded strip line type of technology that can be used for surface mount components. Therefore, you can not have a housing at all and still have a robust mechanical package. So this is a case where a manufacturing technology helps us to control our performance for our historical sort of outside mechanical configuration, as well as allowing us to offer new mounting configurations for our customers in supplying them open PCBs as opposed to something that's necessarily inside of a mechanical housing.
Okay, and I suspect that there might be a few additional types or technologies that would fall into the advanced category.
Absolutely. So now, as far as actually going into manufacturing processes, I gave you a little teaser earlier about when we talk about microstrip. A lot of our advances really have come into automated assembly and our soldering processes. Historically, when we were building microstrip components, we were hand placing resistors and capacitors on these PCBs to make power dividers and couplers. What we are now doing is we now have a pick and place machine in-house, as well as a solder reflow oven, which allows a machine-based manufacturing process to be able to do that assembly work. That does a few things for us, all of which are positive. It allows for accurate placement of the components, just to start with, because since the machine is placing the components much more accurately than you can do by eye under a microscope. And I think really the thing also is that it allows us to put down parts much faster than what we can by hand. I think the biggest advantage of this isn't that, but rather the fact that once these parts get put down using the pick and place machine, they then get sent through a solder reflow oven. A reflow oven, from a reliability standpoint for the solder joints, yields a much more reliable solder joint than anything you can ever do by hand. So therefore, doing this manufacturing process increases our overall MTBF and our reliability on these components. And this is an across the board advantage now that we have, and we can now offer increased reliability because of this manufacturing process. Other things that we've done for some of our higher run products, we have actually designed and built in-house some robotic assembly that allows, again, for more machine-based manufacturing. What this does is it removes a lot of the hand variability, and it allows us to create parts in a much more controlled environment by going to these machine-based processes.
Okay, got it. What about surface mount products? Are they different?
Surface mount products really are similar, but they're different. And you know, TRM historically has built connectorized components. I think with the advent of the multi-layer PCB, as well as with the solder reflow line, I think at this point we can repackage most of our components and most of our connectorized designs into surface mount packages. Directional couplers, power dividers, these sorts of devices can be built using multi-layer technology in a bonded assembly, utilizing plated through holes and embedded resistors. So these are things that we certainly can take virtually any one of our products now and repackage them into a surface mount package. What this does for us is it allows us now to move into new markets. A lot of our existing markets do tend to be high-level system integration pieces where we're delivering parts to the final payload. This will allow us to now to get involved in more board mount components. So we do have that capability. What I will say from a limitation standpoint is that from a cost standpoint, when we do build these multi-layer PCBs for these surface mount components, we get the yield of a panel whether we like it or not. So what does happen there is if you want to get 2 or 3 of them, which is or a very small or a low number, which is kind of typical for a lot of our customers, the cost per unit is still substantial because we have to pay for the entire panel. So really the benefits of going to this technology really come into play when you start talking about some larger volumes. That is what I will say is probably the only drawback to going to this sorts of a product for a lot of our customers, is that we have to find the customer that really needs some volume on some of these components in order to make it effective for both us and them.
Okay, and I've noticed that all of the slides that we've seen so far have shared the title diverse technologies. Why is that important, and how do customers benefit from the fact that TRM is proficient in all these different technologies?
Well, what that really means, Paul, is that really we're not stuck in a corner somewhere saying that we have to build this part utilizing this one technology. TRM can build parts using wire wound transformers and hand placed components. We can use surface mount. We can use pick and place. We can also build things in microstrip strip line. We can build that strip line using a conventional compression technique, or we can go in there and use a bonded PCB. What that really means is that we can design components and manufacture components that will fit into the way our customers expect to mount them into the system. We are not a one-trick pony as far as that goes, and therefore we can truly partner with our customers to design components that meet their needs of the system, and that includes mechanical packaging as well as and mechanical packaging isn't necessarily just making sure we get the right form, fit, and function. Mechanical packaging also says that we're going to meet the environmental requirements of those environments as well. So TRM prides itself on being able to uniquely test for these various environments as they come up.
Does this also mean, Shaun, that if a customer has evolving needs from one program to the next, that since TRM can manufacture in all of these different ways, that maybe they can come back to us and not have to start from scratch to evaluate a custom manufacturer, as we can make changes based on whatever it is they're trying to accomplish?
Yeah, absolutely. I think it's important to really understand that, what we do and the way that we manufacture our products, that we can go with the punches, and we can make sure that we can build the part that they need. I think the other thing also is that if they're going through the initial development of a system, very often they want to have a component that may function like they're going to have in the end system. But the form, fit, and function might be a little bit different for early on development. Well, in that case, maybe we can supply them a standard catalog type part, get the IR&D for them going, and then we can go ahead and work on the packaging secondarily. There's a lot of things that we can do there, and I think that really goes a long way as to why we like to partner with our customers.
Okay, well, thank you, Shaun. Once again, lots of good information. Would you like to summarize?
Sure. And basically, I think what I like people to take away from this is that TRM has been making some very significant investments in both our technology in-house as well as our partners outside to be able to go through it and be able to manufacture some different products than we historically have in the past. I think what that means to our customers is that we can go and we can supply a wider variety of products. We have going to machine-based manufacturing helps control a lot of the manufacturing variables, which increases our yield. It also helps increase the reliability of our products going to surface mount reflow, and those sorts of things. And then the other object I think that I want to point out here really is the fact that because we can now do a lot of multi-layer PCB technology and other surface mount technology, we can now offer new types of packaging to our customers, and not just the conventional connectorized package that we've done in the past.
Okay, well, thank you, Shaun. And we do have a question here, and interestingly, it has to do with packaging. Are there instances when specific packaging requirements dictate the process you ultimately select or propose?
Absolutely. I think if you're looking for a part that is going to mount, for example, on a PCB as part of an internal component that's going to be part of a subsystem, very often it's difficult to get connectors into that system, and that would lead us into a surface mount type component. Once you get into a surface mount type component, you really don't need or really even want to have a metal housing around that component. So that kind of drives you into either a bonded multi-layer sort of component, or if you're talking about a low frequency broadband type of component, where you want to go in there and have a PCB mounted sort of device with sort of a flexible sort of small little cover going on top of it, as opposed to having a robust housing. Because if you're going to be on a PCB inside of a unit, typically it's a box inside of a box scenario, and you don't need that sort of weather tight kind of seal that you would expect on some of the other products. Conversely, if you're going into a part where you are going to be out in the weather and see other sorts of stricter environments, then you very often do want to have a housing around it, even if it is a bonded multi-layer PCB inside the unit. So that interface very often is defined by where it's going in the system and what the overall environment needs are.
Okay, well, thank you, Shaun. And once again, thank you to everyone for joining us today. If you are a customer and you would like to ask more questions or get more information, please feel free to call the free hotline, which is listed here on the screen or displayed, 888-677-6877. We look forward to hearing from you. And if you are one of our field sales representatives, then you know that your calls are also welcome. And you can submit questions directly through the sales rep portal as well, or of course, work through your CAM. And for those of you that might like to have a heads up early, the next Tech Talk is planned for September 21st at 11 a.m. Eastern Time, and the topic is to be determined. Thank you once again, everyone, and thank you, Shaun.
Thank you.